Hello my dear friends, welcome to my YouTube channel. Myself, Dattu Patel, Assistant Professor from LJIT. Today's session, we are going to start with our new chapter, which is Indeterminate Form and L'Hopital rule. First, let's see the basic concept of indeterminate form. In mathematics, several things we cannot define or explain by a logic or words. That means that type of quantities which is called undefined, or we can say that indeterminate form like as 0 by 0 or infinity by infinity. We know that the limit of the quotient of the two functions f of x and g of x can be written as limit x tends to a f of x by g of x equal to separating the limits from numerator and denominator portion. Then we get limit x tends to a f of x by limit x tends to a g of x, where denominator portion must be not equal to 0. But if denominator portion where limit x tends to a g of x equal to 0, then the given result does not give any information about the limits. But here we have the numerator portion, limit x tends to a f of x may or may not be equal to 0. That means limit x tends to f of x equal to 0 or limit x tends to f of x not equal to 0. If numerator portion equal to 0, then we can say that 0 by 0 form, which is our indeterminate form. Suppose denominator portion equal to 0 but numerator portion not equal to 0, then limit x tends to a f of x by g of x does not give any information about the limits, or it is infinite values, means plus or minus infinite value. That means we can say that limit does not exist. Here let's see the few examples based on indeterminate form like as 0 by 0 form. Limit x tends to 0 cos x minus 1 upon x square. Applying the x as a 0 in numerator portion and denominator portion, means value of cos 0, that is 1 minus 1, that is 0. In denominator portion again 0. That means we can say that given example is 0 by 0 form. Similarly, second example which is also 0 by 0. There are the 7 types of indeterminate form like as 0 by 0, infinite by infinite, 0 into infinite, infinite minus infinite, 0 raised to 0, infinity raised to 0, 1 raised to infinite. Let's see the L'Hopital rule for the 0 by 0 form. Firstly, statement: if f of x and g of x are two functions of x having Taylor series in neighborhood for x equal to a and limit x tends to a f of x equal to f of a which is 0 and limit x tends to a g of x equal to g of a equal to 0, then applying the limit x tends to a to the quotient of two functions f of x by g of x equal to limit x tends to a f dash of x by g dash of x, where g dash of a which is not equal to 0. Let's see the proof of the L'Hopital rule. Here, with the help of Taylor series expansion of f of x and g of x in powers of x minus a, then we get limit x tends to a f of x by g of x equal to limit x tends to a with the help of power series expansion or Taylor series expansion f of a plus x minus f dash of a plus x minus a whole square by 2 factorial f double dash of a plus x minus a whole cube by 3 factorial f triple dash of a, and so on. Similarly, in denominator portion in form of g of x function, then g of a plus x minus a g dash of a plus x minus a whole square by 2 factorial g double dash of a, and so on. Here we give the in the statement value of f of a equal to 0 and value of g of a equal to 0. Now substituting that value, the remaining term becomes limit x tends to a x minus a f dash a plus x minus a whole square by 2 factorial f double dash of a, and so on. In denominator portion, x minus a g dash of a plus x minus a whole square by 2 factorial g double dash of a, and so on. Here in numerator and denominator portion, x minus a which is common and cancel out. Then remaining term becomes limit x tends to a f dash of a plus x minus a by 2 factorial f double dash of a and so on. Now applying the limit x as a, then except first term in numerator and denominator portion, remaining all the term has a value x minus a. Then replace x as a, then it becomes 0. Then except first term, remaining all the terms are 0. Then we get f dash of a upon g dash of a. That means limit x tends to a, f of x by g of x equal to limit x tends to a, f dash of x by g dash of x. Now let's see the working rule of the indeterminate form of 0 by 0. Here L, that is indicated by the any which is given to the whatever the question which is given, that is considered as a capital R, or you can any variable y, capital L, etc. Here L equal to limit x tends to a, f of x by g of x, which is 0 by 0 form. Then applying the L'Hopital rule, then exactly what is L'Hopital rule and how you can apply. Then we have the question form f of x by g of x, then separating the differentiation in numerator and denominator portion. Here we cannot apply the quotient rule or u by v rule. Here we have to apply derivative of numerator portion and derivative of denominator portion individually. Again we have to check it is 0 by 0 form or not. If it is 0 by 0 form, then we have to again apply L'Hopital rule, means limit x tends to a, f double dash of a upon g double dash of a. Again we have to check it is 0 by 0 form or not. If it is 0 by 0, then again we have to apply L'Hopital rule. Then it becomes limit x tends to a, f triple dash of x upon g triple dash of x. Now here we get capital L equal to f triple dash of a upon g triple dash of a, where denominator portion must be not equal to 0. Now let's see some standard limits. Here these are the following standard limits for evaluating the indeterminate form, like as limit x tends to 0, sin x by x equal to 1. Secondly, limit x tends to 0, tan x by x equal to 1. Limit x tends to 0, a raised to x minus 1 upon x equal to log a. Fourthly, limit x tends to 0, e raised to x minus 1 upon x equal to log e. Or you all are aware about the values of log e, where base e equal to 1. Fifth one, limit x tends to 0, 1 plus x raised to 1 upon x equal to e. Sixth one, limit x tends to infinite, 1 plus 1 upon x raised to x equal to e. These all are the basically standard limits which is used to solving the examples of indeterminate form, and value of that particular limit which is obtained by the indeterminate form. Now let's see the examples of the based on 0 by 0 form. Limit x tends to 0, e raised to x plus e raised to minus x square minus 2 upon sin square x minus x square. Here firstly we have to check the given limit which is which form. Then we have to apply limit x tends to 0 in numerator portion and denominator portion. Here replace x as a 0 in numerator portion, then e raised to 0 obvious 1, again e raised to 0 obvious 1, x as a 0, then 0 minus 2, then 1 plus 1 minus 2, that is 0. Such a manner in denominator portion, you all are aware about the value of sin 0, that is 0 minus 0, means denominator portion also 0, means given indeterminate form of 0 by 0 form. Then if it is 0 by 0 form, then and then we have to apply L'Hopital rule. Then here with the help of applying the L'Hopital rule, then derivative of numerator portion and derivative of denominator portion individually, means we cannot apply u by v rule or quotient rule. Clear? Then applying the L'Hopital rule means derivative of e raised to x, that is e raised to x, derivative of e raised to minus x, that is minus e raised to minus x, and derivative of x square, that is 2x, or derivative of 2, that is constant, means 0. Such a manner denominator portion, then it becomes sin 2x minus 2x. Again we have to check that term which is indeterminate form or not. obviously it is indeterminate form. Then again applying the L'Hopital rule, then it becomes limit x tends to 0, e raised to x minus e raised to minus x divided by minus 4 sine 2x. Again we have to check given form of indeterminates of naught, then x as a 0, then e raised to 0, 1 minus e raised to 0, 1, then 1 minus 1, that is 0, then numerator portion, that is 0, in denominator portion sine 0, that is also 0, then it is indeterminate form. Then applying the L'Hopital rule, then derivative of numerator portion, that is e raised to x plus e raised to minus x divided by minus 8 cos 2x. Here denominator portion has a finite value, then applying the limit to the given function, then it becomes 1 plus 1 divided by minus 8. Simplified that term, then we get minus 1 by 4, that is our finite answer, means limit exists. Now let's see one more example. Here limit x tends to 1, x raised to x minus x upon x minus 1 minus log x. Firstly, we have to check it is 0 by 0 form or not. Then x as a 1, then x raised to x means 1 raised to 1, 1 minus 1, that is 0. In denominator portion log 1, that is 0, 1 minus 1, that is again 0, means given form which is 0 by 0 form, which given function which is indeterminate form by 0 by 0 form. Now applying the L'Hopital rule means separating the derivative of numerator portion and denominator portion, then it becomes limit x tends to 1. Here you all are aware about the derivative of x raised to x is x raised to x inside the bracket 1 plus log x, which is already learned in earlier standard, minus 1 divided by 1 minus 1 upon x. Again we have to check it is 0 by 0 or not, then it is obviously 0 by 0 form. Then with the help of L'Hopital rule, here x raised to x into 1 plus log x, then we have to apply the product rule, means u as it is derivative of v plus v as it is derivative of u. Then it becomes x raised to x 1 upon x plus 1 log x into x raised to x into 1 plus log x. In denominator portion, derivative of 1 upon x, that is minus 1 upon x square. Now here denominator portion must be not equal to 0, then we have to apply limit to the numerator and denominator portion, and we get simplified it term, it is 2, which is finite. Now let's see one more example. Limit x tends to 0, 10 square x minus x square upon x square into 10 square x. Here we have to use standard limits. Firstly, we have to identify the given function is 0 by 0 or not. With the help of replace x as a 0, the numerator portion becomes 0, also denominator portion becomes 0, means it is 0 by 0 form. Now here multiplying and divide by x square to the only denominator portion for the simplification, then it's become 10 square x minus x square upon x raised to 4 into 10 square x by x square. You all are aware about the limit x tends to 0, 10x by x, that is 1, which is standard limits, and that standard limit we get from the with the help of L'Hopital rule, that is also 0 by 0 form. Now applying that, then our term becomes 10 square x minus x square upon x raised to 4. Now again we have to check given form or of 0 by 0 or not, then it is 0 by 0. Then with the help of L'Hopital rule, limit x tends to 0, 2 10x into sec square x minus 2x upon 4x cube. Again that is 0 by 0 form. Then in numerator portion we have the two product 2 10x into sec square x. Then applying the product rule, u as it is derivative of v plus v as it is derivative of u, and simplified that term, then it becomes 4 sec square x into 10 square x plus 2 sec raised to 4x minus 2 upon 12x square. Again it is 0 by 0 form. Then applying the L'Hopital rule, again simplified that term, then it becomes limit x tends to 0, 16 sec raised to 4x into 10x plus 8 sec square x into 10 cube x divided by 24x. Now we have to separating the limits in both the terms. Then and simplified that term. Then 1 by 24 that is constant, then comes out the limits. Then 1 by 24 limit extends to 0, inside the bracket 16 sec raised to 4x into 10x by x plus 8 sec square x. Here 10 cube x that is divided into two terms, 10x by x into 10 square x. Here limit extends to 0, 10x by x that is 1, and applying the limit extends to 0, then it becomes 16 sec value of sec 0 that is 1, 10x by x that is 1. In second term sec 0 that is 1, 10x by x that is 1, but value of 10 0 that is 0, means 0 into anything 0, then second terms becomes 0, then we have the answer that is 16 by 24. Simplified that term, then we get 2 by 3. Now let's see the one more example. If limit extends to 0, a e raised to x minus b cos x plus c e raised to minus x by x sin x equal to 2. Here in this type of particular example, answer which is given means limit already given. That means we can say that given example has a limit exists. Now we have the limit is 2. Then what is the values of ABC for that type of particular example? Means we have to find the value of ABC, this type of particular example which is limit already exists and limit has a value 2. Now let's see. Here firstly whatever the question which is given, that is our L. Then L equal to limit extends to 0, a e raised to x minus b cos x plus c e raised to minus x upon x sin x. Now we have the limit already given in the question, that is 2. Then we have to finding the value of ABC. That means here whenever we put x equal to 0, then denominator must be 0, but numerator portion has a ABC, that is any constant value. We don't know exactly what is the value of ABC, that is we have to find. Here multiply and divide by x in denominator portion, then we becomes limit extends to a sin x by x that is 1. The remaining term becomes limit extends to 0, a e raised to x minus b cos x plus c e raised to minus x divided by x square. That is our equation number 1. Here the limit of denominator portion is 0. Then we should make indeterminate form. Then for that limit of numerator portion must be equal to 0. That means we have the numerator portion has equation a minus b plus c equal to 0. That is our equation number 2. Then it is in form of indeterminate form. Then we apply L'Hopital rule. Then L equal to limit extends to 0, a e raised to x plus b sin x minus c e raised to minus x upon 2x. Now similarly here again denominator portion equal to 0. Then we should make the indeterminate form. That means numerator portion must be 0. Then applying the limit extends to 0 to the numerator portion, then e raised to 0 that is 1, sin 0 that is 0, and c into a raised to 0 that is again 1. Then it becomes a minus c equal to 0. That is our equation number 4. Now applying the L'Hopital rule, then L equal to limit extends to 0, a e raised to x plus b cos x plus c e raised to minus x divided by 2. Here denominator portion has a finite value. Then applying the limit extends to 0, then it becomes a plus b plus c by 2. We have the value of limit that is 2. Then it becomes a plus b plus c equal to 2. That is our equation number 5. Now we have the solving these equations, means equation number 2, equation number 4 and 5 with the help of Cramer methods or elimination method as you like, and finding the values of ABC, and it becomes a equal to 1, b equal to 2 and c equal to 1. Here let's see the few examples. This is your practice example. Try yourself. I hope you all are learned something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do this share with them. If you watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this topic, then feel free contact me. Thank you so much for watching me.